Hey everybody, it's Mr. Campbell with Mathematical Anarchy. And we're here today talking about combining functions using products and quotients. In our first example, we have a group of friends that travels by foot to reach a volcano and throw a ring into it. We have two functions here. First one being rate, or the speed that the group traveled as a function of the day. And the other function is time that the group traveled as a function of each day. So we notice that the input values of each function are the same. The domain of both functions are the same. So we can actually combine the two tables into one table. The domain is still the same because the inputs are the same, and we can still read off the outputs for each function as we need to. Thinking about the relationship between rate and time, we can use the equation distance equals rate multiplied by time and figure out for each day, based on the rate and the time, how far did the group travel. And we can put that into a new table. For day 0, the group hadn't started yet, so their speed was 0. And the time they traveled was 0, so they traveled a total distance of 0 before the trip started. On the first day, 2 miles an hour multiplied by 6 hours gives us 12 miles. We can continue with the calculations for each day. And ultimately, we can put the values that we find into our table. And we're going to notice that for each day, there's one distance that the group traveled. And that's the definition of a function. So we've created a new function. Again, the domain for all three of the functions is the same, the days from 0 to 5. Looking at the range for the new function that we created, we're going to list all the values from least to greatest. We're not going to repeat, so we're not going to repeat the 12, and we're not going to repeat the 15. Thinking about how this relates to function notation, the general notation would be f times g of x is equal to f of x times g of x. Using the variables we have here, it still represents the distance function is equal to the rate function times the multiplied by the times function. For our next example, a company is replacing gas lines throughout the city. And we can see we have two functions represented. The first function represents the length of pipe that needs to be installed on each day from 1 to 7 days. And the other function represents the crew size, the number of people that will be on the crew for each of those same days. So we have a week's worth of work and a schedule of people that are going to be working. So one thing that we're going to notice is that the domain is the same, the days from 1 to 7. Thinking about the relationship here, we have a certain amount of pipe that needs to be installed, and we know how many people are going to be working. So one question we might ask is, what is the average amount of feet per person that's going to be installed? Okay, what's the work distribution amongst the people? In order to figure that out, we can do some division. We could take the 297 feet of pipe and divide it by the 9 people that are going to be working. And that's going to give us 33. We could do the same thing and take 300 feet on the second day and divide it by the 6 people working, and that's going to give us 50 feet per person. We can continue the calculations for each day, dividing the length of pipe by the number of people until we have filled out our table. We can see that our domain is still the days from 1 to 7, and for each of those days, there's only one work distribution. There's only one amount of feet per person for each day. That's the definition of a function. So we've created a new function using division. Taking our output values and putting those in order is going to give us the range. We can see the least amount of feet per person was on day 7 at 28. That's when there were the most people present. The most amount of work was done on day 4 per person, and that corresponds with the fewest number of people. So it's interesting how in the new function that we created, the maximum of one corresponded with the minimum of the other, and vice versa. Thinking about function notation, we've got f divided by g of x, and that's equal to f of x divided by g of x. Using the variables that we've chosen here, we have w is equal to L over C. The work is equal to the length of pipe needed to install divided by the number of people, the crew size. Okay. So what we've seen is that we can create products and quotients of functions. All we have to do is multiply or divide the corresponding values of the functions that were given. In later units, we'll explore how to do the same thing with equations. Just like with sums and differences, the domain needs to be the same. And in the event that you have an issue with a value in the domain, you can restrict it when necessary. Go ahead and try the practice out. Write down any questions that you might have, and be ready to ask those next class. Good luck.